In this video, we are going to discuss in detail solution of section D of sample question paper for the board exam 2024-25 class 12 mathematics as released by the CBSE board. Section D comprises of 4 long answered questions of 5 marks each. So this section can give you maximum 20 marks. Hello friends, welcome to channel Number Collage. This channel is dedicated to videos on a wide range of mathematical concepts and problems related to them, ranging from high school math to engineering math. Effort has been made to explain the concepts through basic mathematical ideas in a simple English. Hope you will like my effort. Thank you. Question 32. Draw the rough sketch of the curve y equals 20 cos 2x where x lies between pi by 6 and pi by 3. Here we have drawn rough sketch of the curve y equals 20 cos 2x. Let us verify the various points. When x equals pi by 6, y will be 20 cos 2 times pi by 6, 20 cos pi by 3, 20 into half 10, which is this point here 0, 10 for x equals pi by 6. For x equals pi by 4, y will be 20 cos 2 times pi by 4, which will be 20 cos pi by 2, 0. So which is this point here when x equals pi by 4. When x equals pi by 3, y will be 20 cos 2 times pi by 3, that will be 20 cos 2 pi by 3 will be cos 120, which is minus cos 30 minus half, which is minus 10. So for x equals pi by 3, we have this point pi by 3 comma minus 10. A smooth curve passing through these 3 points gives us rough sketch of the curve y equals 20 cos 2x. Next, using integration, we have to find the area of the region bounded by the curve from the ordinates x equals pi by 6 to x equals pi by 3 and the x-axis. So this is the required region of which we have to find the area. So the required area by integration will be 2 times integral from pi by 6 to pi by 4 20 cos 2x, which is 40 times sin 2x upon 2 from pi by 6 to pi by 4, which is 20 times sin 2 times pi by 4 will be sin pi by 2 1 minus sin 2 times pi by 6 will be sin pi by 3 root 3 upon 2. So 20 times 1 minus root 3 upon 2 square units is the required area found by integration. Question 33. The equation of the path traversed by the ball headed by the footballer is y equals ax square plus bx plus c, where x lies between 0 and 14 and a, b and c are real numbers where a is not 0 with respect to a xy coordinate system in the vertical plane. The ball passes through the points 2, 15, 4, 25 and 14, 15. We have to determine the values of a, b and c by solving the system of linear equations in a, b and c using matrix method. Also, we have to find the equation of the path traversed by the ball. We have equation of the path traversed by the ball given as y equals ax square plus bx plus c. From the points through which the ball passes, these points, we will write this equation as for the first point 2, 15. This will be 15 equals 2 square, which is 4a plus 2b plus c. For the second point 4, 25, we have 25 equals 4 square is 16a plus 4b plus c. And for the third point 14, 15, we have 15 equals 14 square 196a plus 14b plus c. We will write this set of equations in matrix form as 4, 2, 1, 16, 4, 1, 196, 14, 1 into column matrix A, B, C equals column matrix of constants 15, 25, 15. We have coefficient matrix A as whose determinant will be determinant A, this one, which we solve, that equals, so determinant A will be minus 240 not equal to 0, implying A inverse exists. Next we will find adjoint A, that will be transpose of this cofactor matrix. So cofactor of this first element 4 will be 4 minus 14 minus 10 etc., and its transpose gives us adjoint A minus 10, 12, minus 2 etc. minus 16. Now we have A inverse equals 1 upon determinant of A into adjoint of A, and the variable matrix X will be column matrix A, B, C equals A inverse into the constant matrix B, that will be 1 upon determinant of A into adjoint A into constant matrix B, that equals minus 1 upon 240 into adjoint A into B, 15, 25, 15. We will take 5 common from each row of this constant matrix, so that will be minus 5 upon 240, 3, 5, 3. So column matrix A, B, C will be minus 5 upon 240 minus 10 into 3 minus 30 plus 12 into 5 60 plus minus 2 into 3 minus 6 etc. That will be minus 5 upon 240 into column matrix 24 minus 384 minus 48, which is 24 into minus 5 upon 240 etc. This will be minus 5 upon 10 minus half 8 and 1. So that gives value of A minus half, that of B 8, that of C 1. Now we will substitute these values of A, B, C in the path traversed by the football headed by the player and get y equals minus half x square plus 8x plus 1 to be the equation of path traversed by the football. Question 34a. A function from R to R, that is real to real, is defined by fx equals cube of mod x. Show that f double dash x, that is second derivative, exists for all real x, and we have to find this derivative. F of x is cube of mod x, the meaning of which is it will be x cube if x is non-negative, and it is cube of minus x, that is minus x cube, if x is negative. We will find left hand derivative at x equals 0, which is limit as x tends to 0 negative f of x minus f of 0 x minus 0 according to the first principles of derivative, which will be limit as x tends to 0 negative of minus x cube minus 0 upon x, that will be limit of minus x square, which will be 0. We name this number 1. Next we find right hand derivative at x equals 0, which will be limit as x tends to 0 positive f of x minus f of 0 upon x minus 0, which will be right hand limit of x cube minus 0 upon x, that will be right hand limit of minus x square, which is 0. We name this 2. From 1 and 2 we have left hand derivative at x equals 0 equals right hand derivative at x equals 0. That implies function f is differentiable at x equals 0, and its derivative will be f dash of x equals 3x square if x is non-negative, and it is minus 3x square if x is negative. Now we will check whether f dash of x as found earlier exists again by derivative from first principles. So left hand derivative of f dash x at x equals 0 is limit as x tends to 0 negative of f dash of x minus f dash of 0 upon x minus 0, which is left hand derivative at x equals 0 of minus 3x square minus 0 upon x, which is left hand limit at x equals 0 of minus 3x 0. We name this 3. Next, right hand derivative of f dash of x at x equals 0 will be as usual limit as x tends to 0 positive of f dash of x minus f dash of 0 upon x minus 0, etc. Right hand limit of 3x at x equals 0 will be 0. We name this 4. Now from 3 and 4 we have left hand derivative of f dash x at x equals 0 equals right hand derivative of f dash of x at x equals 0 equals 0, which implies f dash of x is differentiable at x equals 0. Now we find the second derivative f double dash x of fx. It will be f double dash x equals derivative of 3x square 6x if x is non-negative, and it is minus 6x if x is negative for all x belonging to real set. Question 24b. If x minus a whole square plus y minus b whole square equals c square for some positive c, we have to prove that 1 plus dy by dx whole square raised to power 3 by 2 upon d2y by dx square is a constant independent of a and b. We will compare this given expression with trigonometric identity cos square theta plus sin square theta equals 1. Accordingly, we will put x minus a equals c cos theta and y minus b equals c sin theta. Differentiating this first expression with respect to theta, we get dx by d theta equals minus c sin theta, and differentiating this expression 2 with respect to theta, we get dy by d theta equals c cos theta. We will name them 3 and 4 respectively. Now we have dy by dx equals dy by d theta upon dx by d theta. From 4 and 3, this will be c cos theta upon minus c sin theta minus cot theta. We name this 5. Now we will differentiate both sides of dy by dx equals minus cos theta with respect to theta. That gives d by d theta of dy by dx equals d by d theta of minus cot theta. Now for second ordered derivative, we write this as d by dx of dy by dx of dx by d theta. That will be d by d theta of minus cot theta is minus of minus cosec square theta, which equals cosec square theta. So we get for this part d2y by dx square of dx by d theta, which is from expression 3 is minus c sin theta, which equals cosec square theta. So d2y by dx square becomes cosec square theta upon minus c sin theta. That equals minus cosec cube theta upon c. We will name this expression 6. Now we will come back to the quantity, this one, of which we have to find the value. So we have to find the value of 1 plus dy by dx square whole to the power 3 upon 2 upon d2y by dx square. Now we will substitute the values. 1 plus, we have dy by dx equals minus cot theta according to expression 5 here, square of it, and whole raised to power 3 upon 2 upon, we have d2y upon dx square from expression 6 here, minus cosec cube theta upon c. This will be minus c into 1 plus cot square theta will be cosec square theta raised to the power 3 upon 2 upon cosec cube theta. This will be minus c into cosec square theta raised to the power 3 upon 2 will be cosec cube theta upon cosec cube theta, which gives minus c, which is a constant independent of a and b. Hence proved. Question 35a. We have to find the shortest distance between the lines L1 and L2. Say these lines whose vector equations are this one and this one. We name this vector as A1 bar to be the position vector of point A and this vector as B1 bar, which is the position vector of parallel vector to line L1. Similarly, we will denote this vector as A2 to be the position vector of point B on line L2 and this vector as B2 bar, which is a parallel vector to line L2. Now we have a formula for the shortest distance D, that is distance AB, as D equals mod of B1 bar cross B2 bar dot A2 bar minus A1 bar upon mod B1 bar cross B2 bar. We will find these quantities separately and substitute in this formula. So first let us find B1 bar cross B2 bar. That will be determinant I cap, j cap, k cap. 7 minus 6 1, 1 minus 2 1, which after evaluation will be minus 4 I cap, minus 6 j cap, minus 8 k cap, and its magnitude will be square root of minus 4 square 16 plus minus 6 square 36 plus minus 8 square 64 square root of 116 to square root of 29. Next we find A2 bar minus A1 bar. 3 minus minus 1, 4 I cap, 5 minus minus 1 plus 6 j cap, 7 minus minus 1 plus 8 k cap. We have found out B1 bar cross B2 bar to be and A2 bar minus A1 bar to be, and their dot product will be minus 4 into 4 minus 16, 6 into minus 6 minus 36, 8 into minus 8 minus 64 minus 116. We have found out mod B1 cross B2 to be square root of 106. Now the required perpendicular distance D will be mod of minus 116 upon square root of 116, which will be mod of square root of 116, which will be square root of 29. So the required shortest distance between lines L1 and L2 will be 2 square root of 29 units. Question 35b. We have to find the image of the point 1 2 1, which is P here, with respect to the line this one. We call this line as AB and write its equation here. We also have to find equation of the line joining the given point P and its image Q, which we have assumed to be x1, y1, z1. We assume each ratio in the equation of line AB to be a constant lambda, and we know that every point on line AB, such as the foot of the perpendicular of segment PQ on segment AB, will be of the type lambda plus 3, 2 lambda minus 1, 3 lambda plus 1. From this we will find direction ratios of PM as lambda plus 3 minus 1, lambda plus 2, 2 lambda minus 1 minus 2, 2 lambda minus 3, 3 lambda plus 1 minus 1, 3 lambda. And from the equation of line AB, we have DRs of AB are 1, 2, 3. Now since PQ is perpendicular AB, product of DRs of PM and AB will be 0. So therefore we write 1 into lambda plus 2 plus 2 into 2 lambda minus 3 plus 3 into 3 lambda equals 0. After solving this equation for lambda, we get lambda equals 2 upon 7. Now that we got the value of lambda, we write coordinates of point M as 2 upon 7 plus 3, 2 into 2 upon 7 minus 1, 3 into 2 upon 7 plus 1, which will be 23 upon 7, comma, minus 3 upon 7, comma, 13 upon 7. Now since Q is image of point P in line AB, point M is this one, midpoint of segment PQ. So by midpoint formula, 23 upon 7 equals x1 plus 1 upon 2 minus 3 upon 7 equals y1 plus 2 upon 2, and 13 upon 7 is z1 plus 1 upon 2. After solving these three equations, we get coordinates of Q to be 39 upon 7 minus 20 upon 7, 19 upon 7. Now we have coordinates of P 1 to 1 and that of Q 39 upon 7 minus 20 upon 7, 19 upon 7. So direction ratios of segment PQ will be 39 upon 7 minus 1 minus 20 upon 7 minus 2, 19 upon 7 minus 1, which will be 32 upon 7 minus 34 upon 7, 12 upon 7. Removing the common factors, the DRs will be 16 minus 17, 6. Now equation of line PQ will be x minus this 1 upon this direction ratio 16 equals y minus this 2 upon this direction ratio minus 17 equals z minus this 1 upon this direction ratio. So this is the required equation of PQ, and the coordinates of image of point P in AB, which is Q. Friends, if you like this video, please like, share and subscribe this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.